All right, topic 11, midpoint, distance, and Pythagorean theorem. Really, I reordered them, so it should be like midpoint, Pythagorean theorem, and distance, but whatever, it doesn't matter. Okay, so midpoint, first things first. So if you have 2 points, like, let's look at, well, I'll draw like a little picture here. Let me draw a little picture for you. So say we have like a point over here and a point over here on our graph. So each one of these points has like an x and a y number. That's how it gets on the graph, an x and a y number. And say we want to find the point like directly in the middle. So like the point directly in the middle of these would be like maybe like right here. Does that look like it might be in the middle? Yeah, looks pretty close. We could call M for middle. Maybe these outside ones are called like point A and point B. Okay, how would we get the like x and y points for this middle thing? Well, what we have to do is like the side to side is going to be the exact middle of like the x's on the side. So in order to get the exact middle, we'd have to like add the 2 x's together, like the x from A and the x from B, and then divide them by 2 to get halfway in the middle. And then to get the up and down distance, well, that's just the y from the A plus the y from the B divided by 2, like the average of the y's to go up and down. And that's how we get this nice midpoint formula right here. So the x number is the average of the beginning x numbers, and then the y number of the midpoint is the average of the y numbers from the endpoints. Yeah, okay. Hopefully that picture is kind of helpful. Let's do an example here. So it just says find the midpoint of these guys. So our answer is going to be a point, like it's going to be like an x and a y. We're going to get an x and a y. So the new x that we want, the x for the midpoint, we have to take the x's from the original one. So we have to do like negative 3 plus 4 divided by 2. And that ends up being negative 1/2. Okay, and then the y, to get the new y for the midpoint, we have to do 6 plus negative 2 divided by 2, which ends up being 4 divided by 2, which is just 2. Nice. So our midpoint is just the point negative 1/2, 2. And if we draw a little picture, I think we'll be able to see that. Ooh, I have an idea. Let's steal, what if we steal a graph? Oh, look, like these, no, those are graphs that are tied in. Can I find another graph? Ooh, how about like one of these graphs? Okay, let's see if I can steal this. Oh, yeah, okay. But how do I like share? Oh, copy. Okay. Where were we? Right here. Oh, okay. What if I like paste this right here? Paste. Oh my gosh, yes. I'm just gonna make it kind of small. Then we can zoom up on it. Okay, so I'm going to put these 2 endpoints in first. So like the point negative 3, 6, let's put that on here. So negative 3 up 6. Here's the point negative 3, 6. So it's like the point A, negative 3, 6. And then we'll put the point B. Okay, so that's 4, negative 2. That was our other endpoint. So 4, negative 2 is right here. So over 4 down 2. That's like our other endpoint. And then our midpoint, let's see, I want to make it orange because I don't know why. So our orange, negative 1/2, 2. So negative 1/2 means you go left 1/2 and down 2. Oh, it's not supposed to be negative 1/2. Look at this. Negative 3 plus 4 is like a positive 1. Totally a positive 1. This should just be 1/2. Right? Yeah. Negative 3 plus 4 is positive 1. You probably caught that before and you're like, oh my gosh, Miss Murphy, I can't believe you did that. But you know what? Catching your mistakes after the fact is still good. We learn from mistakes. So 1/2. Okay. Whew, 1/2, 2. I figured something was wrong because negative 1/2, 2 would be like up here, and that doesn't look like it's right in the middle. So 1/2, 2 is to the right 1/2 and then up 2. That looks better, right? Doesn't that look like it's right in the middle? Look what I could do. I wonder if I can like connect the dots here. Yeah, see, like that looks like right in the middle. That was a good midpoint. I think we did a good job. Nice. That's the midpoint. 1/2. Oh. Go back to the pen. 1/2, 2. Nice. Good job. Cool. So that's midpoint. Average the x's, average the y's. Okay, Pythagorean theorem. So our good buddy Pythagoras, who died because he thought beans were holy and wouldn't run into a field when people came to get him because he was doing stuff with like irrational numbers and people thought he was like really bad or something, he figured out that if we have a right triangle, so a right triangle meaning we have like a perfect 90-degree corner. Here's a 90-degree corner. The legs of that triangle, so the sides next to the 90-degree angle, we'll call them A and B. If you square them and add them together, so A squared plus B squared, that is equal to the long side squared. So we have A squared plus B squared equals C squared. We love this formula. Okay, here we're going to try it. Here's our right angle. Here's our 90-degree angle right here. So we have 7.2 as one of the legs plus 9.6. So these are the ones like right next to the right angle. Plus 9.6 squared. That's going to equal the long side, which we're going to call C squared. And we're trying to get C by itself. So 7.2 squared plus 9.6 squared. Let's do that on our calculator. So we have 7.2 squared plus 6 squared. Enter. Ooh, okay, that is 144. So can I like pull this over? Well, okay, so this is 144 equals C squared. But we are trying to get just C by itself. So in order to get just C by itself, we're going to just square root both sides. In other words, we're wondering what number do we multiply by itself? Like what number squared is 144? The answer is actually going to be 12, but we can do it on our calculator just to make sure. So square root, to get the square root, you have to do like this button right here that we were using for the squared. We have to hit second and then that button, and that will get a square root. 144, enter 12. Nice. So that means this little triangle. What if I want this to just like gently go away? Just please leave. Well, it'll just gonna watch me mess around with this. Oh, well no, that is not what I wanted for sure. There we go. Okay, so the actual dimensions for this triangle is like 9.6 across, 7.2 tall, and then 12 all the way across this way, like the diagonal side. Okay, one more of these. So we have distance. So the distance formula looks really scary. It's actually just a fancy way of doing A squared plus B squared equals C squared if you like turn your head and look at it and squint, right? So let's do an example of this. So it says find the distance between the points -3, 6 and 4, -2. So our first point, we'll just like label these x1, y1, x2, y2. These little 1s and 2s, they don't mean like powers, it's not like squared or anything. It's just saying like this came from the first set of points and this came from the second set of points. So it's just like labeling them so we know where they came from. That's what's going on in our formula here. It's just saying like, oh, this is the x from the first point, this is the x from the second point that we gave you. So we just got to fill in our formula. So d equals square root. Okay, x1 minus x2, so -3 minus 4 squared plus y minus y, so 6 minus -2 squared. So here's our formula, and we got to put that in our calculator. So let's mess with this calculator again. Oops, that's not what I wanted. I'm doing a really good job here. No! Just come up just softly. Yeah. And put it over top. Okay. So we have to do square root. So square root is over here. Careful, open up parentheses, be careful with the negatives and the minuses. So -3 minus 4 squared plus 6 minus -2 squared. And that's all in the square root. If I enter, I get 10.63. So our final answer is just 10.63. It's not very like satisfying, but it's 10.63. Okay, so 10.63. And well, let me show you again. So I'm gonna steal this thing again. Oh, can I still, like, do I still have that copied? Can I just paste it down here? Oh yeah, okay, cool. So let's plot these 2 points and I'll show you what I mean. So the point -3, 6. The point -3, 6 is -3 up 6, and we have 4, -2. This is the same points we used above, I think, but now we're looking at the distance in between them. So when we like connect the dots here, connect the dots, that's what we're wondering. We're like, how long is this? What's this distance? Okay, and what we really did, look here, if we make this a right triangle, it's like we do not have a triangle, but what if we like made one? Like, we have to give this credit for going down and over. So how far down does this line go? Well, it goes 1, 2, 3, 4, 5, 6, 7, 8, right? So it goes down 8, and it goes over 1, 2, 3, 4, 5, 6, 7. So it goes down 8 and over 7, right? Well, let's do 8 squared plus 7 squared. 8 squared plus 7 squared, because that's the 8 and the 7. Okay, 8 squared plus 7 squared is, let's see, 8 squared plus 7 squared. 8 squared plus 7 squared is 113. Okay, that's 113. Okay, what if we do square root of 113? Square root of 113 is, second square root 113. 10.63. About went around, so I'll put the like squiggly lines, about 10.63. So that's why the distance formula is really just a fancy way of doing like a squared plus b squared equals c squared. You can kind of see how we like made a right triangle in here, and then we did 8 squared plus 7 squared, and then ended up square rooting it. So, and we got 10.63. All right, that is midpoint distance and Pythagorean theorem.